Good morning, students. So this is the second part of the regression analysis. So regression line and regression coefficient. In the first part of the regression analysis, we discuss about the regression line x on y and y on x and set of equations to calculate a and b. Now here we have some different equations. First is the y minus y bar is equals to r standard deviation y divided by standard deviation x minus x bar, and second equation is x minus x bar is equals to r standard deviation of x standard deviation of y bracket y minus y bar. So these two are the regressions line. The first is y on x and second is x on y respectively. Here r is the correlation coefficient, sigma x standard deviation of x, sigma y standard deviation of y, x bar is mean of x, y bar is mean of y. So these two are the regression lines. If we have some information like we have mean value, standard deviation, correlation coefficient, then easily we can calculate the regressions line through these two formulas. The first is y on x and second is x on y. So now in these two equations, the important thing is we have this portion, basically this portion, the coefficient of x in the first equation and the coefficient of y in the second equation is basically a regression coefficient. So this is a regression coefficient. This is a regression coefficient of y on x and this is a regression coefficient x on y. So now I am taking one example. From the following information, summation of x is equals to 20. So from the following given information, summation of x is equals to 20, summation of y is equals to 30 and the number of observation is equals to 5. Standard deviation of x is 3, standard deviation of y is 4 and r, the coefficient of correlation, is equals to 0.6. Things are given, information is given of the data. Now they want to calculate regression lines. Value of y when x is 0.8, value of x when y is 10. So to solve this illustration, we have a note which we have to remember, the relation between the correlation coefficient and the regression coefficient. Basically we have correlation coefficient small r and regression coefficient we have two. One is y on x, another is x on y. So the relation between the correlation coefficient and the regression coefficient is r is equals to square root of regression coefficient x on y and y on x respectively. The multiplication of regression coefficient and its square root is equals to the value of r, where regression coefficient the correlation coefficient is basically lies between -1 to +1. So now we are going to solve this illustration. We have all the information given and we have to calculate three things. The first regression line, second the value of y and third is the value of x. Now let's see how we will solve it. So here the given information is summation of x is 20, summation of y is 30, n is 5, standard deviation of x is 3, standard deviation of y is 4 and r is 0.6. So here the mean value of x will be summation of x upon n, which is 20 by 5, 4. Summation of y upon n means mean of y is 30 by 5, which is 6. Now the first thing which we need to calculate is regression line. So we have two regression line, y on x and x on y. So one by one we will calculate. So regression line y on x, formula is y minus y bar, r standard deviation of y upon standard deviation of x, x minus x bar. So y minus, the value of y bar was 6, r 0.6, standard deviation of y 4, standard deviation of x 3 and bracket x minus x bar is 4. If we will calculate it, so y is equals to 0.8x plus 2.8. This is the first equation which is y on x. In this equation the coefficient of x 0.8 is regression coefficient y on x. So v by x is equals to 0.8. Similarly the regression line x on y and the formula we have x minus x bar is equals to r standard deviation of x, standard deviation of y, y minus y bar. We will put all the values, all the information which are given in the illustration. X minus x bar is 4 is equals to r की value 0.6, Standard deviation of x is 3, standard deviation of y is 4, y minus y bar is 6. If we calculate it, so the x is 0.45y plus 1.3. This is your equation number 2, regression line x on y. In this regression line, the coefficient of y 0.45 is the regression coefficient x on y, because here the equation is x on y. dxy is equals to 0.4. After getting these two regressions line, the second point we need to calculate y when x is equals to 0.5. If x is given, that means the independent variable is x, and we need to calculate y, means dependent variable is y. So we will put in the first equation the value of 0.8 in the first equation, x की value 0.8, then we will get y is equals to 3.44. Similarly, in the third part, we need to calculate value of x if y is given. If y is given, means y is the independent variable and x is the dependent variable. So here we will put in the second equation. So x is equals to 0.45. We will put the value of y 10. Then we will get x is equals to 5.8. So this is the way that we can calculate the regression coefficient, regression lines, and the values of x and y respectively when the x and y are given, y and x are given. Here we can calculate one more thing. We can calculate that R, which is the relation between the regression coefficient and correlation coefficient. So this is bxy and byx, means 0.8 into 0.4.